look at some basic number sets. The first number set is usually abbreviated with an uppercase N, and it's the set of natural numbers. Natural numbers are frequently thought of as your counting numbers. And if you think about counting, you start with 1, 2, 3, and we're going to put an ellipsis, a dot, 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 to say that set goes on forever. The next set of numbers is W, is the whole numbers. And the whole numbers are the natural numbers with a little bit more. We're going to include 0. I remember one of the first times I learned about the difference between natural numbers and whole numbers, I was told that the 0 is like drawing a hole at the beginning of the set. Then we go on to the idea of ratios. And a ratio can be thought of as a comparison of two numbers. And so I might think of a ratio as being a comparison A to B, which could be written as A colon B, or it can also be written as a fraction A over B. And as a fraction represents division. Sometimes we're asked to express a ratio as a fraction in simplest form. So an example might be something like 24 to 36. And that ratio, 24 to 36, I can think of as the fraction 24 over 36. And then to reduce that fraction, to simplify it, I want to divide both the numerator and denominator by the same numbers, so that would reduce to the fraction 2/3. Instead, let's look at another example. Let's look at the ratio of 75 to 60. As a fraction, that would be 75 over 60. I can divide both the numerator and denominator by 15, which gives me the ratio of 5/4. You want to leave it as an improper fraction. You don't want to change that into a mixed number. We're going to leave it as an improper whenever we see the words as to express as an integer in simplest form. As a ratio, of integers. And then one last example. Let's say I have a ratio of 12.5 to 50. Here, if there is a decimal, what we want to do is we want to multiply both the numerator and the denominator, the top and bottom of the fraction, by a multiple of 10, so that there is no decimal left. So what does that mean? If I look at that 12.5 times 50. I'm going to start multiplying numerator and denominator by 10, which will give me 125 over 500. And now that there's no decimal left, now we're going to reduce. And to reduce that 125 over 500, I believe both the numerator and denominator can be divided by 25, which would give me 5 over 20, and that can still be reduced by another factor of 5, so it'll give me 1/4.
So when we look at rates, we're also looking at ratios. If I have 15 miles per hour, I look at that word per almost like being the slash line in a fraction. So that's 15 miles over 1 hour. So for example, if I'm asked to express 15 miles per hour in miles per minute, well, let's see, that's 15 miles over an hour. But we know an hour is 60 minutes, so that's 15 miles over 60 minutes. And so that 15 over 60 will reduce to 1 mile in 4 minutes. Now, if I want to express that as a unit rate, I want to divide that fraction out. 1 divided by 4 will give me 0.25 miles per minute. A proportion is an equation that sets two ratios equal. A proportion might be something like A over B equals C over D. We know a proportion is true when the cross products are equal. By cross products, I mean, if again I only have one fraction on each side of the equal sign, if I multiply diagonally across the equal sign, that would give me A times D equals B times C. And for a proportion to be true, those products must be equal. So let's look at an example. Is 15 over 35 equal to 21 over 49? And when I look at my cross products, that would be 15 times 49, and the other cross product would be 35 times 21. Since both products equal 735, yes, it's true. So now what we want to do is we want to try to solve a proportion. When we're trying to solve a proportion, we need to first introduce the idea of a variable. A variable is a symbol whose value can change. Just like in life, if something's variable, it can change. Examples commonly used are things like x and n. The opposite of a variable is a constant. If something's constant, it's always the same. So an example of a constant might be something like 2. Our numbers are our constants. A variable expression contains a variable, constants, and symbols of operation. So an example might be x plus 3. Another example might be something like 4n. But remember, if there's no symbol in between the constant and the variable, it means I'm multiplying. So that's actually 4 times n. Different than an expression is an equation. What makes something an equation is that it contains an equal sign. So to solve a proportion, it's a particular type of equation. Let's say, for example, we have x over 225 equals 3 over 25. To solve it, first I'll cross multiply, setting those products equal. So that gives me 25 times x is equal to 3 times 225. When I multiply, that gives me 25x equals 675. That 25x, that 25, that constant factor is called my coefficient. And so now what I want to do is divide both sides by the coefficient. So dividing by 25, I get 25x divided by 25 is equal to 675 divided by 25. We've got to do the same thing, the same division to both sides of the equal sign. On the left, when I divide, I get x. On the right, I get 27. If we look at another example, let's say I have 7 over 20, equals x over 100. When I cross multiply, I get 7 times 100 is equal to 20 times x, or 700 equals 20x. I need to divide both sides by the coefficient on x, so I'll divide both sides by 20, and I get x equals 35. Next, we're going to look at applications. Applications are our word problems. When you solve a word problem with proportions, it's important to pay attention to your units. I like to write the ratio in words. And you have to, when you set up those ratios, be consistent. The same units have to be the same place in each ratio. So let's look at an example. A medicine dosage is 300 milligrams for every 40 pounds of weight. What is the dosage for a man who weighs 175 pounds to the nearest tenth? Well, I'm going to look and see what am I comparing. I'm comparing the medicine to the weight. So I'm comparing milligrams to pounds. So first instance, I get 300 milligrams to 40 pounds. And now I'm looking for the dosage. So x is going to be in the place of the milligrams, and that 175 is in the pounds, and we've declared that the pounds go in the denominator. So now when I cross multiply, I get 40x equals 300 times 175, or 40x is equal to 52,500. Dividing by 40, I get x is 1,312.5 milligrams.